Okay, so we are looking at section 4.4, part 2. This is going to have to do with how we can completely factor a polynomial if we have one factor given to us. Okay? So this is going to be a little bit different than what we have been doing. One thing I want to remind you is that when we do synthetic division, what does synthetic division tell us when we find that remainder? What does it tell us? What's the remainder the same as? Nobody knows? The remainder is the same as the y value. So when we do synthetic division, the remainder is equal to the y value for that x. So whatever x we put in the box, or sometimes we want to think of that as k, whatever k value we put in the box, the remainder that we get, that's going to be the y value for that specific x. So here's the factor theorem. It says a polynomial f of x has a factor of x minus k if and only if f of k equals 0. So that's telling us that when we do synthetic division, if we get 0 for the remainder, then this would be a factor. Okay, let me do just a real simple problem. All right, so let's say we have this problem. X squared minus 2x minus 15 equals 0. Can you guys think of an x value that would make that equal 0? Probably not off the top of your head, but if we factor this, how would this factor? What are numbers that multiply to be 15 and subtract to be 2? 3 and 5. And we would need the 5 to be negative and the 3 to be positive. So that means that my solutions are negative 3 and 5. So when I plug in negative 3 into this, I would get 0. If I plug 5 into this, I would get 0. Watch with synthetic division. I put 5 in the box. I put my coefficient 1, negative 2, negative 15. I bring this down, that's 1. Multiply, add. Multiply, add. See how that works? We knew that 5 was going to be a solution to this. And we knew that x minus 5 was a factor. But to check that, I could do synthetic division. When this is a factor, or when 5 is a solution, I get that remainder of 0. Look at this example now. Determine whether the binomial is a factor of the polynomial. Here's our polynomial, x cubed plus 3x minus 6. Here is our binomial. We want to know, is this a factor of that polynomial? What's the k value? 2, so I'm going to put 2 in the box. The coefficients are going to go 1, 0, 3, negative 6. Coefficient, there was 0 is the coefficient of x squared, 3 is the coefficient of x, and negative 6 is our last one. We bring this down, we multiply and add, we multiply and add, we multiply and add. What did I have to get here in order for this to be a factor? 0, did we? No, so therefore, no. It is not going to be a factor of the polynomial. In example 2, it says to show that the binomial is a factor. So now they're telling us it definitely is a factor. And then factor the polynomial completely. What's my k value? Negative 2, so that's going to go in the box. Coefficients are 1, 2, negative 9, negative 18. I bring this down. I multiply and add. Multiply and add, multiply and add. Is it going to be a factor? Yes, and it's supposed to be. So here is my remainder. This is going to represent the constant. This is the x term. This is the x squared term. So what I'm left with then, after I divide, is x squared minus 9. I'm supposed to factor this completely. How does x squared minus 9 factor? It's the difference of two squares, isn't it? So my polynomial, though, completely factored, is going to be x plus 3, x minus 3, plus the one that they already told us. And that would be the complete factorization. To check to make sure I have all the factors, I can say I've got x times x times x. What is that? X cubed. And that's what I'm supposed to have, is x cubed. So therefore we know that that's probably correct. Could you have factored this another way? How could you factor that another way? By what method? We just talked about it today. Grouping. Watch. If I had just factored this by grouping, I would have factored out an x squared and had x plus 2. Factored out a negative 9 and had x plus 2. I'd have x plus 2 and x squared minus 9. See how I'd end up getting the same thing if I did factoring by grouping? Okay? Alright, so factoring by grouping, we could have done that even without knowing this binomial. But look at this. We have no way of factoring this. X cubed minus 13x minus 12. We don't know how to factor that. But it's going to tell us one of the factors. So what am I going to put in the box? Negative 1 goes in the box. Coefficient is 1, then 0, negative 13, and negative 12. We're going to bring this down. Multiply, add, multiply, add, multiply, add. What does this now represent? Can somebody tell me? This is the constant, that's the x squared. So what's it going to be? X squared, then what? Can we factor that now? X and x? What are numbers that multiply to be 12 and subtract to be 1? 4 and 3, so it's going to be minus 4 and plus 3. So to show the complete factorization, though, of f of x, I know it's these two plus what other one? X plus 1. They gave us that. There's the complete factorization. So by knowing one of the factors, we can then find the rest of it. All right, let's do another one. Let me see which one I want to do. That one, we would have to know that. This one you could probably do by grouping, but let's go ahead and do this one anyway. What goes in the box? So now I'm going to have my coefficient here is 2, coefficient here is negative 12, this is 6, this is 20. Anybody know what else I would have to put though? A 0 for the constant. I bring this down, multiply, add, multiply, add, multiply, add, multiply, add. All right, so I'm left with this. That's good because this is supposed to be a factor. So this would be my constant term, this would be my x term, this is my x squared, and this is my x cubed. So after I did my division, I'm left with 2x cubed minus 2x squared minus 4x. What should I do first to factor this? What's the GCF? So I'm going to factor out a 2x, and I'm left with x squared minus x minus 2. Are there numbers that multiply to be 2 and subtract to be 1? So this is going to factor down into x minus 2 and x plus 1. But I'm trying to find the complete factorization of this. That means I've got x times x times x. That's only x cubed. It's not x to the 4th. What are we missing? X minus 5. So I've got to have the 2x, x minus 2, x plus 1, and x minus 5. All right? Make sense? Okay, let's do a real-world problem now with this. During the first 5 seconds of a roller coaster ride, the function h of t equals 4t cubed minus 21t squared plus 9t plus 34 represents the height in feet of the roller coaster after t seconds. How long is the roller coaster at or below ground level in the first 5 seconds? So this is a roller coaster. It's starting right here. It goes up a little bit, it goes down, and it actually goes down below ground level. Right here would be the ground, and then it comes back up. We're actually going to answer these questions first, and then we're going to come back and answer how long is the roller coaster at or below ground level in the first 5 seconds. What is the height when the ride begins? What would I plug in for t to find this height when it begins? 0. Do that. 0, 0, 0. What is it? So it's 34 feet high. What is the lowest point that the roller coaster goes? Well, here's the lowest point. I don't think we know of any way to find that lowest point unless we use our calculator. We're going to have to go to y equals. I'm going to type it in. So after I get it typed in, I want to look at it. How can I get just a normal screen? What do I push? Zoom 6. I'll see if that's a good representation. And it's not so great, is it? I want it to look more like this. So I can see that their time is going from -2 to 7. So I'm going to go to my window. My x is going to go from -2 to 7. I can see their y's are going from like -20 to 100. So my y min, I'm going to make -20. My y max 100. Now I'm going to take a look at it. Much better. Ooh, still not quite low enough. I want to make that -40 on the y min. There we go. That's good. Okay, so what is the lowest point that the roller coaster goes? Do you guys remember how to find this lowest point? Where is it located? Second, trace, which one? Minimum, number 3. Make sure you're on the left side of the minimum, which I am, so I push enter. Arrow over until you're on the right side of it, push enter. Enter one more time, and the lowest value it goes is -21.26 feet. So it goes that far underground. What is the coaster's height at 5 seconds? How could I quickly find that since I already have it in my calculator? Go where? Table. Go to the table. When x is 5, 54 feet. Why do you think h of t is not an accurate function for the entire time the coaster is traveling? Why do you think it's not a very good...
Because it doesn't show the whole roller coaster.
Okay, but what else? What do you think? There you go. John is right. This is going to come down like this, but this is never going to go back down. It just keeps going on up to infinity. That'd be a little scary if it just kept going up forever. So, never comes back down. And the reason is because it's a cubic function. Cubic functions always have that kind of pattern. So that cannot be the representation for the whole thing. All right, last question now. How long is the roller coaster at or below ground level in the first 5 seconds? So I have this point and this point. Can I think of a way that I can find that time? Can I see this time? It looks like I can see it even. What is that time right there? 2. So why not just use synthetic division? I know it's at 2 seconds, so I'm going to plug this in. And I'm going to do this. 4, that's 8, that's negative 13, negative 26. That'd be negative 17, that's 34, negative 34. 0, great. So that was 2. That had to be 2 because it gave me an answer of 0. So now I'm going to take this. 4x squared minus 13x minus 17. I want to know what are my other zeros? Because if I know that 0, then I'm going to know the answer. Let's see if we can factor it. 4 times 17 is 68. That's 1 and 68, or 2 and 34, or 4 and 17. Will any of those subtract to give me 13? Which ones? 4 and 17, okay. So we're going to do this. We know it's 4x and x. I need to get a 4, so that's got to be a 1. I need to get a 17, so that's got to go there. Let's see, I want a negative 13x. So this is negative, this is positive. What's the solution then? Well, we've got 4x minus 17 equals 0, x plus 1 equals 0. What's this going to be? 17/4, right. What's this going to be? Negative 1. Do I care about negative 1? No. But I do know that this is 17/4. What's that as a decimal? 4.25, right. So this is going to be 4.25. We knew this was 2, so how far is it from 2 to 4.25? 2.25 seconds. That's how long you would be underground. Now that's not the only way I could have done it. I could have done this on my calculator. I could have looked at the graph, I could have gone to y equals, and I also could have found the this point by finding that intersection right there. So I could have done second trace, calculate, intersect, get over there close to it, enter, 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 and it tells me 4.25 is that point, right? So we have so many different options here. We can do it algebraically or with technology. All right, any questions on that? Okay.